NMR spectroscopy. This was the initial idea that then led to MRI. So in the MRI, you're surrounded by a magnet. You're placed inside of a magnet. The same thing we do here, we put the sample into a magnet. The magnetic field here is much, much stronger than the MRI magnet, but the same thing happens is all of your protons line up, all of your hydrogen atoms line up with the magnetic field. And that's a requirement in order for the method to work. And it gets kind of complicated exactly what's going on in there, but it tells us something about the environment, the chemical environment those protons are in once they're in that magnetic field. So molecules are very tiny entities, and there's no way to actually take it, unfortunately you can't just take a picture of a molecule. So the way we get information on molecules is kind of a roundabout method. So it's kind of like if you were blind and you wanted to know what someone's face was like, you can't see it, but you can get an idea about it by touching them. And so this is sort of the roundabout way of getting information on a molecular scale. This gives us information about the hydrogens on the molecule and the carbons on the molecule, and we take all that information and put it together to come up with a unique structure, whatever that molecule is. On a daily basis, well, not on a daily basis, but very often we generate molecules that are brand new to the world, that have never existed before. So this gives us a way to demonstrate that the molecule actually has the shape and the structure that we're saying it has, and be able to demonstrate that to the greater chemical community. Being able to do that is critical to carrying on any kind of new research. So organic chemistry and many of the other branches of chemistry require being able to know what those molecules look like and what those molecules are doing. In the absence of that, we're just shooting blind. So really, it's got the critical, it can do something that no other piece of instrumentation can do, and that's give us this kind of information about the structure of molecules and individual atoms within those molecules. It's pretty typical for these things, it's at least around 10 or 15 years without an issue, and then after that, you have to, like you was talking about, maybe have to re-engineer the current a little bit or do whatever to get things going again. But you've got to probably 20, 25 years on an instrument like this without any kind of major problem. That's a big part of what we do at Berry College, is to get students involved in research, which leads to their being distinguished as chemists when they leave Berry, and that gets them great positions, going into jobs, and also great positions at graduate school. A number of our students go up to graduate school to get their PhDs in chemistry, and having this kind of research is essential there. So at a big university, at an Emory University or Georgia Tech, they'll have maybe 10 of these types of instruments available. Some of them 3 times the size of that instrument over there. So they're doing the same kind of analysis. The bigger the magnet, the more precise it becomes when you're looking at these structures.